In this video, you're going to be preparing for the geometry midterm exam. With this giant review, we're going to be going through a number of different types of questions, a number of different types of examples. So let's jump into this video, and if you want to go to a particular problem or type of problem, go to the description below. I've got timestamps there that'll take you right to that type of problem so you can focus on that concept. But let's go through these one by one here. So the first question says, name the intersection of plane O and plane P. Okay, so remember, a plane is a flat surface, right? And we're trying to find the intersection, basically what they share in common or where they cross. So let's see. So when we look at this plane here, what's the intersection of this horizontal plane and this vertical plane? Well, if you take a look, you can see that they're actually crossing at this line right here. And you could label this line as line GF, line DF, line FG, and so on. But basically when you have two planes that intersect, they're going to cross at a line. So I'm just going to call this line D F, and you want to put that line symbol above it to indicate that it's a line and not a segment, because remember, planes keep going, in two dimensions like that. Okay, now part B says name one pair of opposite rays. Now this is a typical question. A lot of students get this incorrect, and when you label opposite rays, what you want is you want to have the same endpoint. Now when you think of an endpoint is basically like a starting point, and it goes one direction like a ray of sunshine. It heads out from that point. But opposite rays, they have the same endpoint, but they're going 180 degrees opposite direction. So together they form a line. So when you look at this diagram, do you see a pair of opposite rays? Well, we've got a couple of different options. One option would be like ray DA and ray DB, or we could say ray DC and ray DE, or ray DF and ray DG. But the key point here is you don't want to have the rays going like this. So this is a common mistake that students will make. They'll look at one ray like this, one ray like this. Or say, for example, you have a line and they'll say, I'm going to use this endpoint, and I'm going to go this direction, and I'm going to use this endpoint, and I'm going to go that direction. So they're overlapping. They don't have that same initial starting point. So in this example, there's a lot of right answers, but I'm just going to say ray DF and ray DG, and also notice that the ray is always pointing to the right. Even though the ray might be going to the left in the diagram, this is just the notation. So you can see this is the starting point D, and then it heads towards F and keeps going. Here it starts at D, heads towards G, and keeps going. So let's go to question number 2. Now what you might want to do with some of these questions is see if you can do them on your own. Pause the video and then we can go through them together so you can kind of see if you're on the right track, if you're understanding the concepts. So it says if WY equals 18, so this whole length right here is 18, and XY is 6 right here, find WX. Now whenever they say WX like that without a bar over it, that means the length of WX, okay? So saying what's the distance from W to X. Let's label this here. So we have XY is 6. We know that this whole length right here is 18. So what do you think the length of WX is? Well, if you said 12, you're absolutely right. And this is testing us on what they call the segment addition postulate. So segment addition postulate means that the two segments add up to the length of the whole segment. Very important when you get into your geometry proofs. Okay, so now question number 3 says, given the segment MN with M has the coordinates 2, 7, and N has the coordinates of 7, 19, find the midpoint of segment MN. Okay, well, part B says length of MN. Okay, so two different things that they're testing us on, and these are very important questions. One is basically testing us on the midpoint formula. With the length, it's actually testing us on the distance formula. So let me write down those formulas here for us so we can analyze them a little bit further. So midpoint, what you're doing is you're adding the X coordinates up and you're dividing by 2. And you're adding the Y coordinates together and dividing by 2. Whereas for the distance formula, you're taking the square root of the difference in the X coordinates squared plus the difference in the Y coordinates squared. Then you add them together and take the square root. So in this case, what I'm going to do with the midpoint is I'm going to take 2 plus 7. So I'm adding the X coordinates, so that's 9, divided by 2, which is 4.5. And if we add the y's together, 7 plus 19 is 26, divided by 2 is 13. So that's going to be the halfway point, the midpoint. But if we want to find the length, okay, the distance between these two, now we're going to be subtracting the x's. So I'm going to say 7 minus 2, which is 5, squared. And then I'm going to say 19 minus 7, which is 12, squared. Add those together and take the square root. Now 5 squared is 25, 12 squared we know is 144. If we add those together, we get the square root of 169, which is equal to a length of 13. And you've got it. So again, review your midpoint and distance formula. Okay, question number 4, they give us this diagram here and it says classify the angles. So the first one says classify angle AOD. Now remember, when you write an angle, the middle letter is the vertex. That's the hinge of the angle. So we've got angle AOD. Now notice how this is forming a straight line. This is actually called a straight angle. So I'm just going to write straight. Okay. Now letter B says angle FOA. So let's trace that out. So F to O to A. Now remember again, that little middle letter is the hinge. That's the vertex of the angle. But notice that that angle is less than 90 degrees. So we call that an acute angle, right? Acute. And then letter C, angle EOB. So where's EOB? EOB. Okay, so if we trace that out, we can see that one's more than 90 degrees. We call that an obtuse angle, OBTUSE. And then the last one says angle FOD. And let's see where angle FOD is. We've got FOD, and you can see again that also is greater than 90 degrees. That's going to be obtuse. Notice this box right here, this square, that indicates that angle EOD is a right angle or 90 degrees, but in this case FOD is greater than 90, so again we have another obtuse angle. Okay, so that's classifying angles. Now number 5, they give us this diagram here, and it says find the measure of angle YXZ. So where's YXZ? Y to X to Z. So we're trying to find out the measure of that angle. But the thing to notice here is that, see how WXZ, see how that forms a straight line? Okay, that's a straight angle. These two angles here are called a linear pair. Pair means two, linear means they form a line. And we know that when they form a line, that's 180 degrees. So if we add these two angles together, that's going to add up to 180 degrees. So that'll allow us to solve for X. Now, one mistake that students often make when they're doing these problems, they get caught up in the algebra. And I don't know if this happens to you at all, but you know, when you're solving this, okay, I'm just going through this, you can see that X is equal to how much? 176 divided by 4, what does that come out to? So that's 44, okay? But a lot of times what students will do is they'll say, okay, the answer is 44, but remember it's asking us what's the measure of angle YXZ? Well, we have to put that back in here, 44 in place of X, that's 44 plus 12, so it's actually going to be 56 degrees. So don't make that mistake. If you do the algebra, make sure you're answering what they're asking for. Okay, now number 6, it says if a pair of complementary angles have measures of 3x plus 2 and 5x minus 8, find the measure of the two angles. Okay, now what they're testing us on in this problem is, do we know the definition complementary and supplementary? Complementary means the angles add up to 90, right? And supplementary means they add up to 180. But in this case, if they're complementary, all we have to do is add them together and set them equal to 90 degrees. Okay, so we're going to combine like terms. That comes out to 8x minus 6 equals 90. Add the 6 to the other side. Divide everything by 8. So we get x equals 12. But again, remember, just like the previous problem, we have to put 12 back in. That's going to be 3 times 12 is 36, plus 2 is 38. And if we put 12 in here, we get 60 minus 8, which is 52. And if you want to double check yourself, if you add these together, you can see they add up to 90, so we know we're on the right track. Now number 7, it says if a polygon has 7 sides, name the polygon. Now that's kind of funny because 7 sides, question number 7, right? Okay, so what is the name of a polygon that has 7 sides? Well, this one sometimes students forget. It's a heptagon, okay, heptagon. Remember, 6 sides is a hexagon, 5 is a pentagon, 4 is a quadrilateral, 3 is a triangle. What's 8? Octagon. 9, nonagon, it kind of sounds like 9. 10, decagon, like 10 years in a decade. Okay, but in this case, 7 sides, heptagon, that's the one you want to put. Okay, question number 8. They give us this triangle here and it says find the perimeter, find the area. Okay, so you probably remember this from your pre-algebra class, but remember perimeter is the distance all the way around the object. And so what you would do is you would add up 7 plus 8 plus 5, and that comes up to 20. And whatever the units are, it's just going to be the units. If it's centimeters, it's centimeters. If it's inches, it's inches. In this case, it doesn't write the units, so I'm just going to write units. Now the area, what they're testing us on, of course, is the formula for the area of a triangle, and what you want to memorize is 1/2 base times height. So the base is the bottom, that's what the triangle sits on. The height is the perpendicular distance. So you don't want to accidentally use 7 or 8. You want to use this perpendicular height. That's the shortest distance from the vertex to the base. Okay, so that's 6. So what we have is we have 5 times 6 times 1/2. So let's write that down, 1/2 5 times 6, that's 30. Half of 30 is 15. But here what you want is units squared. Okay, so for area, it's two-dimensional, and you're trying to fill it up with 1 by 1 squares. Okay, now number 9, they're giving us a circle, and it says what's the radius of the circle and what's the circumference of the circle. Okay, so again, they're testing us on some basic formulas here, but remember, the radius is the distance from the center to any point on the edge of the circle, so it's like a spoke of a wheel. But what they're giving us here is the diameter, 12 inches. We have to cut that in half, so the radius is going to be 6 inches. Now the circumference is a fancy name for the perimeter of a circle. It's the distance all the way around. And we want to remember this formula for circumference. It's 2 pi r, 2 times pi times the radius, or you could say, since 2 times the radius is the diameter, so you double the radius as the diameter, you could say pi times diameter. So since they give us the diameter is 12, it's just going to be 12 times pi, and that's an exact answer, but you could put 3.14 in for pi and then, use that as an approximation. So I'm just going to say 12 pi inches. Okay, so a couple formulas to memorize: 1/2 base times height and circumference. Okay, for number 10, excuse me, it says given the sequence -7, 14, -28, 56, describe the pattern and write the next term in the pattern. Now you might be saying to yourself, well, this doesn't seem a lot like geometry, and they throw this at you in your geometry class, but what this is really testing us on is inductive reasoning. So can you follow a pattern? Can you make a conjecture about what the next point, the next figure is in the pattern, and so on? Well, you can see, so in this case, the pattern, it looks like what we're doing is we're multiplying by -2 each time. So that would be the pattern. The next term would be 56 times -2, which is going to be -112. Okay, so again, that's inductive reasoning as opposed to deductive reasoning, which you're going to be doing when you get into the proofs. You're using the laws of logic, and etc. Now, number 11, it says the product of two numbers is always greater than the larger number. So here it says, what kind of a statement is this? The product of two numbers is always greater than the larger number. Well, this is called a conjecture, and I accidentally said it over here when we were doing that problem, but conjecture, it's basically like, you're making an educated guess based on the facts and figures that you have, and it's not proven though. We're just making this conjecture saying, well, this is what I think it is. Now, is this true or false? Well, okay, remember, product means you're multiplying or timesing the two numbers together. And when you multiply two numbers together, is it always greater than the larger number? Well, let's take an example. Let's say, for example, 1/2 times 16. We know that equals 8, right? But 8 is not larger than 16, so this is false. Okay, so we showed an example where it's false, and this says if false, give a counterexample. So this is our counterexample. It basically shows where it doesn't work. So you can't really prove something by giving example after example after example, but you can disprove it by showing one example, at minimum, where it doesn't work, and that's enough to say, hey, something's not right with this conjecture, must be false, and back to the drawing board, right? And then letter C says rewrite as a conditional statement. Okay, so a lot of definitions here, but conditional statement is basically what? It's an if-then statement, right? It's saying if the hypothesis, right? If the hypothesis happens, then the conclusion will occur. So it's an if-then statement. So how could we rewrite this? So if you multiply two numbers together, okay, then the product will be greater than the larger number. So see how I switched it from just a statement like this into an if this happens, then this will happen. So if you multiply two numbers together, then the result will be greater than the larger number. So if, then. So that's conditional. Okay, question number 12 says, two parts. It says if it snows more than a foot, then the schools will close. And it says if school is closed, then the test will be moved back a day. So we've got two different conditional statements. And it asks us, what is the contrapositive of statement 1? Okay, and then it also asks, what's the converse of statement number 2? Okay, so what we want to go through really quick here are the different types of statements. So we've got a conditional statement, which looks like this. If P, then Q, right? So this is the hypothesis, this is the conclusion. The converse is like this. You reverse them, if Q, then P, right? So it's like saying it backwards or in reverse. And then the inverse is where you negate the hypothesis and a conclusion, but you keep them in the same order. That's called the inverse. And then the contrapositive is a combination of the converse and the inverse. You switch the hypothesis and conclusion, and you negate them both. So that's what these symbols mean here. So it's a quick way of just remembering. So you have conditional, converse, inverse, and contrapositive. So what I like to do is whatever comes after the if, I like to underline. That's the hypothesis. Whatever comes after the then, I like to underline. That's the conclusion. So this is like our P, this is like our Q. And so if we say what's the contrapositive, we have to switch these and negate them. So what the contrapositive would be, it would be if the schools, I'm just abbreviating here because we only have a little bit of room. So if the schools don't close, see, do not, so I'm negating it. If they don't close, right, then what happens? Then it did not snow more than a foot. Then it did not snow greater, I'll just say greater than 1 foot. Okay, so do you understand what we did? So we switched the hypothesis and conclusion, we negated them both. Now for the converse of statement number 2, it says if school is closed, then the test will be moved back a day. So again, what I like to do is underline whatever comes after the if. That's the hypothesis. Whatever comes after the then, that's the conclusion, right? And so the converse is like saying it backwards. So we're switching them. We're saying if the test will be moved back a day, then school is closed. Now, it doesn't necessarily mean that just because we can write these statements that they're true, okay? So the converse is not necessarily true. You have to test it out. But basically, what all I'm doing is I'm just switching it. So I'm saying if the test, okay, is moved back a day, moved back, I'm just abbreviating, right? Then, right, school was closed, right? School was closed. All right, so that's how you work with those. So let's look at number 13. So it says name the following properties. So here we're getting into some of the properties. If AB is equal to BC, then BC equals AB. Which property is that? Notice all we did was we switched the AB and the BC like that. Well, that's called the symmetric property. So you want to memorize that. So when you change the order, it's like a line of symmetry. You can fold over that line of symmetry. It's the same saying it forward or backwards. Measure of angle A equals a measure of angle A. Well, obviously anything's going to be equal to itself, right? But what's that called? Well, that's called the reflexive property. And you can remember that. It's like looking in a mirror. You're the same height in the mirror as you are in real life, right? Unless it's like some kind of a convex or not a flat mirror, right? Okay, so reflexive, anything is equal to itself. And then the third one here, it says if AB equals BC and BC equals DF, then AB is equal to DF. So what property is that? It's kind of like if I'm as tall as you are and you're as tall as your brother, then I'm as tall as your brother. So what is that? That's called the transitive property, right? It's like a train. It's like the first is connected to the second is connected to the third, the first is connected to the last or the third. Okay, so that's the transitive property. So symmetric, reflexive, transitive, we use these a lot in geometry, so definitely review those. Okay, now number 14, we're starting to get into proofs a little bit here, and they start off by giving us an algebra proof, something that you did, solving an algebra equation last year or in algebra, but now we're actually justifying the steps. So what we're doing is we're writing this as a 2-column proof. This is the statements on the left. These are the reasons on the right. Sometimes they call them the justifications, but we're just going to say statements and reasons. Now the first statement is, usually write this first, it's the given, okay? They're going to tell you something that's true, some type of starting point, something that you can assume is true, and then they'll tell you what to prove, okay? And then that's usually going to be your last statement, but what we have to do is we have to fill in the in-between statements to tie it together, right? So let's take a look. So if you were solving this in algebra, what would you do? Well, the first thing I would do is I'd probably go like so, right? So what did I do? Well, you can see I distributed the 2. So I'm just going to write step number 2, and I'm just going to say that's the distributive property. I'm just going to abbreviate, distributive property. Okay, then what's the next step? What would you do if you were solving? Well, you probably would do something like this, right? So what's that called? Well, I would just call that simplifying or combining like terms. So I'll just say combine like terms. All right. Okay, now how about step number 4? Step number 4, I probably would, let's see. I'm going to see if you can figure out what I'm doing here. So, okay, so what you can see here is I subtracted the 3x from both sides, and I subtracted the -8 from both sides. So as long as you do it to both sides, that's called property of equality. In this case, it's the subtraction property of equality. So I'm just going to write subtraction property of equality. I'm just abbreviating. Okay, so then the last step is what? Okay, and we've got our answer, and that you can see I divided both sides by -9, so that's called the division property of equality. So that's an algebra proof, and we know how to solve algebra equations again, but the only thing that's different now in geometry is we're actually justifying or giving the reasons why we can go from one step to the next step to the next step. Generally, like I said, we start with the givens. Usually we end up with what we're trying to prove as the last step, and we're just trying to fill in the intermediate or in-between steps, okay? So that's an introduction there to proofs. Now, number 15, it says, they give us this rectangular prism here, and it says name a line that's skew to line HG. So where's line HG? So that's this line right here, okay? And what does it mean when two lines are askew? Well, we know what it means when two lines are parallel, right? Parallel means that the two lines are in the same plane, right? Same plane means the same like flat surface, and they don't cross, they don't intersect. But what skew lines mean are like, here's one line like this, like my arm, and here's another line going like this. Now they don't cross, but you can see they're in two different planes. You know, it's like one is up here, right? And let's say maybe like one is kind of like over here, like this, right? So here's a line, okay? And in this case, it looks like they actually would cross, okay, but that's not the best example. So like, let's take a look over here in this diagram. So where's two lines that are in two different planes, two different flat surfaces, but they don't cross? Well, okay, I'm going to extend line HG a little bit so you can see it a little bit better, okay? But you see this line here like CB? See, this is like over here on the left side of the box. This is on the right side of the box. Even if I extend this line up and down, and I extend this one over here like so, these are never going to cross. It's like two airplanes. It's like, why don't planes crash in the air? Well, one's at this altitude, one's at this altitude. They're not going to cross because they're at two different, you know, heights, basically, two different planes. And so that's one example. You could also use line AD. What you wouldn't want to do is do HE. These would cross at point H. You wouldn't want to do line EF because these are actually parallel. They're not crossing, but they're in the same flat surface. You could do line DF. That would work, okay? So there's a lot of correct answers for that one. And then part B says name a plane that's perpendicular to plane HGA. Now HGA is the front of this rectangular prism, the front of this box. We want it to be perpendicular, meaning it forms a right angle. So a good example here would be, let's see, HGA is the front. We could do maybe the base of the box. So we could do plane ADF, for example, ADF. Okay, but here what we're doing, instead of talking about perpendicular lines, right, forming right angles, we're talking about perpendicular planes, something like this, right? Let's see if I can draw this here for us. See, they're forming a right angle, the two planes. Okay, so that's a little bit about talking about skew lines, parallel lines, perpendicular lines. If you're enjoying this course and you like my teaching style and you want to prepare for the ACT math section or the SAT math section, check out my two huge review courses. One's for the SAT math section, one's for the ACT math section. So we have a teaching section, there's example problems, we go through formulas, we go through different types of problems like you would see on the test and talk about how to approach them, how to solve them. So check out the 3 free previews that I have available for each of those 2 courses. If you're interested, a lot of students have taken them and reported back that they've improved their scores. And so I hope that you'll take advantage of that as well. And if you're interested in online tutoring with me, you can contact me. I'll have a link for that. If you want to do some FaceTiming or if you want to use the shared whiteboard that I use when I work with students online via Skype, we can do that as well. So let's get continuing with this video though. Question number 16, this is a really important concept. You've got 2 lines, okay, in this case M and N, and they're cut by a third line, which is called a transversal. And you can see in the process, there's 8 angles that are formed. So a really important concept for geometry. And it says classify the angles, meaning, you know, are they corresponding, are they alternate interior, are they vertical, and so on. So let's see, angle 1 and angle 4. Well, when you have 2 lines that cross like this, where they form an X, the angles that are across from each other, either these 2 or these 2, those are called vertical angles. And if the 2 lines are basically like this, they're going to be congruent or equal to each other. It's like a pair of scissors, right? So in this case, we're going to say vertical angles. Okay, angle 1 and angle 8. Okay, so angle 1 and angle 8, these are actually called alternate, because see how one's on the left side of this transversal and one's on the right? But they're outside of these 2 lines like this. That's called exterior. So 1 and 8 are called alternate exterior. I'm just going to abbreviate AE, alternate exterior. Angle 4 and angle 5. Okay, now these again, one's on the right, one's on the left, but now they're in between those two lines. So this is called alternate interior, okay? And then let's see, 5 and 6. So 5 and 6, you see how they form a line like that? And they're right next to each other. That's called a linear pair. And these are going to be supplementary. These are always going to add up to 180 degrees like a straight angle. So I'm just going to write LP for linear pair. Now angle 4 and angle 6, notice how these are on the same side of this transversal, okay? And they're in between the two lines M and N. So those are called consecutive interior. Consecutive, like one after another. Interior meaning in between the two lines. So don't get those confused. You've got alternate interior like 3 and 6, 4 and 5. Consecutive interior is like 4 and 6, 3 and 5. Now let's look at angle 3 and angle 7. So 3 and 7, a lot of times students mix this one up. These are called corresponding angles. Basically, you see how this forms like an X, and you see how this forms like an X. If I pick this X up and I place it on top of that X, the angles that match up with one another, that correspond, those are called corresponding angles. So you have like upper left-hand corner, upper left-hand corner, upper right, lower right, and so on. They correspond or match up. So I'm just going to write corresponding angles. We'll just write corresponding angles. Okay, and then let's see, letter G says if M and N are parallel. Now notice here we didn't even say anything about the lines being parallel. And you can still classify them like we did. But if line M and N are parallel, and angle 6 is 70 degrees, so let's just put that in here, 70 degrees, find the measure of angle 3 and the measure of angle 4. Well, angle 3, that's an alternate interior angle. That's going to be congruent with angle 6, so that's going to be 70 degrees. Angle 4, on the other hand, this is a consecutive interior angle, or sometimes they call it a same side interior because it's on the same side of the transversal. These two angles are supplementary. So in this case, this angle would be 110 degrees. So just a quick review, alternate exterior are going to be congruent. Alternate interior are going to be congruent. Vertical angles are congruent. Corresponding angles are congruent. The ones that are supplementary are the ones that form a linear pair, or the ones that are consecutive interior, like 4 and 6, 3 and 5. Now what's interesting about this diagram, I'll just make one last note about this, is that when you have two lines that are parallel, cut by a transversal, let's just say this angle here is 120. What you'll notice is that all the obtuse angles are 120. All the acute angles, in this case, are 60. So even though that we have 8 angles total, there's only 2 angle measurements, okay, 60 and 120 in this case. So very important concept. So let's go to number 17. It says find the value of x that makes line M and P parallel. So what do these values of x have to be so that these two lines are parallel? Now what we're talking about right now is these two angles are corresponding angles. See lower left-hand corner, lower left-hand corner. Okay, we talked about picking up that x and placing it on that x. The only way that these two lines will be parallel is if the corresponding angles are congruent. So this is called the corresponding angles converse theorem, because we're saying it backwards in order to prove line M and P are parallel. So we have to set these equal to each other. This is just a little bit of algebra, but the key thing is to make sure you know that they're congruent and not supplementary. So let's go ahead and subtract 4x from both sides. Let's add 2 to both sides, divide by 2. You can see that x equals 6, and we got it. Okay, now number 18, it says a line passes through the point 2, -8 and 4, 6. Find an equation of the line in slope-intercept form. Okay, now remember slope-intercept form is y equals mx plus b. So it feels a little bit like we're going back to Algebra 1, but this is also part of geometry. And so what we're going to do is we're going to find our slope, which is m. And remember, the slope formula is the difference in the y values over the difference in the x values. So I'm going to take -8 minus 6 over 2 minus 4. And you want to keep that order consistent. I did y2 minus y1 over x2 minus x1. So that's -14 over -2, which gives us a slope of 7. So we've got y equals 7x plus b. I just put the 7 in for m right there. But now to solve for b, what do? Well, we take one of these points. I'm just going to take this point here. I'm going to put 6 in for y, since that's the y coordinate, 4 in for x, and I'm going to solve for b. So what do we get? We get 28. Okay, and if I subtract 28, that gives us -22 equals b. And what we can do is we can put that back in for b right here. So y equals 7x minus 22, and you got it. Okay, number 19, it says, Here's line 1, it goes through these 2 points. Here's line 2, it goes through these 2 points. Are the lines parallel, perpendicular, or neither? This is a common question, definitely something you want to remember. But the way we figure out if the lines are parallel is if they have the same slope, because they're going up at the same angle, and that's why they don't cross. But if they're perpendicular, meaning they form a right angle to one another like this, okay, 90 degrees, then the slopes are what we call opposite reciprocals. Like if one is 3/2, the other one will be negative 2/3. So the sign flips and the fraction flips, okay? So let's go ahead and figure out what these slopes are. So 6 minus 4 is 2. 3 minus negative 2 is 5. So this is line 1. 1 minus 6 is negative 5. 3 minus 1 is positive 2. Okay, when we look at these two slopes, you can see they're opposite signs. One's positive, one's negative, and they're reciprocals of one another. So I flip one of them over to get the other one. So that means that these lines are actually going to be perpendicular. They form a right angle. So that's going to be the best answer for that one. Now, if they were both 2/5, then they would be parallel. And then if it was like 2/5 and 3, for example, then that's neither. They're going to cross, but not at a right angle. Okay, question number 20. If you're enjoying this video and it's helping you, make sure to give this video a thumbs up. That'll let me know to make more midterm reviews and final exam reviews like this for you guys. So number 20 says, write an equation of the line through this point and parallel to this line. Okay, so what they're asking us here is, do we know how to write the equation of a line? Do we know what it means for lines to be parallel? And remember, when you have parallel lines, what do we know? We know that they have the same slope, but they don't necessarily have the same y-intercept. So I'm just making the y-intercept here, the b value, just as b. Now, if we want it to be parallel, and we know it goes through this point negative 2, 1, let's put the y-coordinate 1 in for y, and let's put the x-coordinate negative 2 in for x, and we just have to solve for b now. Now, a lot of times students get a little bit stumped here when you have a fraction in a whole number. Well, the key is to make that whole number into a fraction by putting it over 1. So what you have here is you multiply the numerators and the denominators together. That's negative 6 over 2, which is negative 3. So now we have 1 equals negative 3 plus b. Add the 3 to the other side, and you can see that b equals 4. We just have to put 4 back in here for b, and you've got it. So y equals 3/2 x plus 4. That's the equation of your line parallel to the given line, but it goes through this particular point. Okay, now number 21, it says find the value of x and classify the triangle. Okay, now what they're testing us on in this problem is, do we understand that all the angles in a triangle add up to how much? 180, right? So all we have to do is write an equation. So we've got x plus 3x plus 1 plus 43 equals 180. So x plus 3x, that's 4x. 1 and 43, that's 44, equals 180. Subtract the 44 from both sides. That gives us how much? 136. And divide by 4, how much is that? Well, let's see. That's, is it 39? Let's see. 34. Okay, 34. So then what we want to do, so x is 34 degrees, and if we put 34 back in, that means that this angle's 34. 3 times 34 is how much? Well, let's see, that's 90, that's 102, plus 1, that's 103, right? Yeah, so it's 103. So basically, if we want to classify this triangle now, because one of the angles is more than 90, that means that this is an obtuse triangle. If they were all less than 90, it would be an acute triangle. If two of the angles are the same, it would be a isosceles triangle. If they were all the same angle, like all 60 degrees, then it would be an equilateral triangle or an equiangular triangle. Okay, you can use either because they're both. But in this case, we're going to say it's an obtuse triangle. Okay, because one of the angles is more than 90. Okay, now number 22 says classify the triangle by its sides, okay, by its side lengths. Here we classified it by its angle measures. So here you can see that there's two sides that are the same. So that means that this is going to be an isosceles triangle. If all the side lengths are different, it's going to be scalene. Okay, if they're all the same, it's equilateral. Okay, if they're all different, it's scalene. If they're all the same, it's equilateral. If two are the same, it's isosceles, right? So two different names, one by the angles and one by the number of, by the side lengths. Okay, number 23 now, they give us this diagram here and it says find the measure of angle 1, 2, and 3. Okay, so it's kind of like a puzzle, right? Or like a maze or something you're trying to solve here. But remember, we know that all the angles add up to 180. And we learned that, vertical angles are congruent, linear pairs, those two angles add up to 180 and so on. So let's see if we can work our way through this diagram. This little square here means 90. Okay, so I'm just going to pencil that in. If this is 120, see how these two angles form a line? They're a linear pair. That means this is 60. And you can see that 90 plus 60 is what? 150, which means angle 3 is 30. Okay, so we figured that one out. And then let's see what else we have. If this is 120, this is 60, or you can see that these are vertical angles because they form that X. The angles that are across from each other are congruent, right? Let's see, what else do we know? Well, we know that this is 90 and 60. That's 150, which means that angle 1 must be 30. Okay, good. And now we know this is 15. Okay, so angle 1 is 30. Let's put that in here. And then if this is 15 and 120, that's 135. That means that angle 2 must be 45 because all three of these angles have to add up to 180 degrees in a triangle, right? So that's what you do, is you work through your diagram like that. And I usually like to write right on the diagram so I don't have to remember, what the measures are. I can just kind of look at the diagram as I go through it and just work through it. So number 24, find the measure of angle A. Now, you want to look at the diagram for hints or clues, and notice that they show us that these two sides have the same markings. That means that they're congruent, or they're the same length. That means it's an isosceles triangle. And the important things to remember about isosceles triangles are that the base angles, or the angles that are across from those congruent sides, okay, these are called the base angles, these are congruent. So that means that we can set these equal to each other. So if we do that, let's make an equation here. 2x plus 5 equals 3x minus 10. Subtract the 3x from both sides, that's negative 1x. Subtract the 5 from both sides, that's negative 15. Multiply both sides by negative 1, and we get x is 15. But it says find the measure of angle A. Again, we have to put that back in. 2 times 15 is 30, plus 5 is 35 degrees. Okay, so you're with me so far? So do the algebra, but make sure you answer the question. Sometimes you have to put it back in. Now number 25, A and B, it's asking us, are these two triangles congruent? Are these two triangles congruent? Now remember, there's 5 different ways to prove triangles congruent that we learned in geometry. What are the 5 different ways? See if you can remember them. There's side, 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 meaning that 3 sides in one triangle are congruent to 3 sides in the other. We've got side, angle, side. Okay, we've got angle, side, angle. We've got angle, angle, side, and we've got hypotenuse, leg. That's when you have a right triangle and a right triangle. The hypotenuses are the same, and one of the legs in one triangle is congruent to one of the legs in the other triangle. So let's see what we have here. Now, they give us clues, and that's what you want to look for. They already tell us that these sides are the same, okay, by this marking. They tell us that this line is parallel to this line, and what I like to do is extend those lines, and you can even extend the transversal like that, so it looks more like that diagram we were working with earlier in the review. And now what we can see is that these angles are going to be congruent, okay, because they're alternate interior angles. Okay, remember this diagram, right? Alternate interior. And then we know that they share this side. Okay, this side is shared between the two triangles. So now look what we've got. We've got side, angle, side, side, angle, side. Okay, so these two triangles are congruent, and we can prove that using the side, angle, side triangle congruence theorem. Okay. Now over here, again, they also show us that these lines are parallel, so we could extend these two lines if we want. We notice that vertical angles, the angles that are across from each other when they two lines cross, like in that X formation, those are going to be congruent. We know that these angles are going to be congruent by alternate interior. These are also congruent by alternate interior. You might be tempted to say angle, angle, angle. Now, you can see angle, angle, angle is not one of the triangle congruence theorems that we have, so we can't actually prove that these triangles are congruent. They're similar, meaning that one triangle might be proportional to the other. They might be exactly the same. It might be a 1-to-1 proportion, but we can't prove that. We know that they're similar, meaning that the corresponding angles are congruent, but the corresponding sides are proportional. But we can't prove that if I cut this out and match it up with that one, it's going to be an exact match that they're congruent. So in this case, can't prove it, no. This one, yes, side, angle, side. Definitely an important concept. You want to review these triangle congruence theorems. Okay, question number 26. So is everyone picking up some good pointers on their geometry midterm review? I hope so. So let's see. So to prove that BC is congruent to DA, so this segment is congruent to this segment, what would you prove first? Okay, that's a good question. Okay, so a lot of times on a midterm exam, they don't have time to have you prove like all these proofs, so they just try to pick out little bits and pieces of a proof so they can kind of test you on multiple concepts within a given time frame. So basically, if we wanted to show that this segment is congruent to this segment, now notice that these two lines are parallel, not necessarily congruent. Ideally, what we want to do is show that this triangle is congruent to this triangle. Then by the CPCF or the CPCTC, the corresponding parts of congruent triangles are congruent, that we can show that those parts are congruent. But how do we prove these two triangles are congruent? Well, first of all, when two triangles share a side like that, you know that BD is congruent to BD by the reflexive property. So anything's going to be congruent to itself. Also, we know that this angle ADB, is congruent to this angle DBC by alternate interior angles, okay, because these are two parallel lines cut by a transversal. But I think what they're looking for in this problem is show that triangle ADB is congruent to triangle, let's see what that would be, CBD, triangle CBD, and that's by the angle side triangle congruence theorem. So angle side, remember the 5, side angle side, and so on. But angle side, once we know the triangles are congruent, then by CPCTC, or some books use CPCF, the corresponding parts of congruent figures will be congruent. Well, let's go to question number 27. So they give us these 3 coordinates, okay, and I've plotted them here for us. And it says, let's see, what does it say? The coordinates of B prime, find the coordinates of B prime after reflection over the line y equals x. Now remember, the line y equals x is a 45-degree line like that. But when you reflect over that line, what happens is, this is the formula that you want to memorize, is that the coordinates AB become BA. They actually interchange. And you can see, let's see, where's point A? It's 1, 0. Now you can see it's going to be over here at 0, 1. So we're basically reflecting or folding over that line, and you can see that point's going to match up with 0, 1. So I've got a whole video talking about rotations, reflections, and the rules. But here, reflection over the line y equals x, you switch the x and the y coordinates. Okay, now for the second part, it wants us to find out what's the rotation of this triangle, 90 degrees, okay, and I should have specified counterclockwise, so going this direction, 90 degrees about the origin, okay. So the thing that we want to know here are, how do you rotate points A and B 90 degrees? Well, it's going to be negative B, comma A. So what you do is you switch the x and the y coordinates. You make the new x coordinate the opposite sign. Okay, so if we do that, let's switch them first. That might be a little bit easier. So 0, 1, 1, 4, 3, 2, and then we're going to make the new x coordinate the opposite. Of course, the opposite of 0 is still going to be 0, so I'll just leave it like that. Now, if we plot those points, you can see that 0, 1 is here, negative 1, 4 is going to be right about here, and negative 3, 2 is going to be right about there. So I don't know if you can see this, but you're turning it 90 degrees about this point. Okay, so again, review that video if you want to review how to do the rotation. So I'll give you another example. Like if you rotate 180 degrees, AB would become negative A, negative B, so that they stay in the same order, but you just make them the opposite sign. If you rotate 270 degrees counterclockwise, AB becomes B, negative A. So you switch the x and the y, and you make the new y coordinate the opposite sign. So those are for rotations. Reflections are a little bit easier. If you reflect over the y-axis, what happens is AB just becomes negative AB, so the x coordinate's the opposite. If you reflect over the x-axis like this way, then you have AB goes to A, negative B. So this is reflecting over the y, this is reflecting over the x, okay? So definitely review those formulas. That's very important. Okay, now number 28, if segment SU is a midsegment of triangle RTV, find the length of RV. Now remember, when they don't put a bar over it, that just means the length of RV, the distance between R and V. And this is called the midsegment theorem, and basically what it means is if this is a midsegment, it's connecting the midpoint of this side to the midpoint of this side, and this is going to be parallel to the base, the midsegment, and it's going to be half of the base, which means that the base is going to be double, so this is going to be 24. So that's the midsegment theorem. Okay, number 29, it says, given this rectangle WXYZ, find the coordinates of point W. Okay, so this is like what they call a coordinate proof or a coordinate type problem, but they tell us it's a rectangle. We know these are 90-degree angles. We know that the opposite sides are congruent. And so what we have to figure out is, okay, how do we find the coordinates of this point? Well, if we're going right A, okay, comma 0, so this length here is A. Here you're going left A, so this distance is A, okay, but negative because you're going to the left. Here, see this AB, you're going right A, up B, so that means this height of the rectangle is B. That means this would also be B. So to get to this point, we have to go left A, so negative A, up B, that's positive B. So the coordinates of point W would be negative AB. Okay, question number 30. they give us this diagram here, and it says if line L, okay, which is this horizontal line here, is the perpendicular bisector of segment AB, okay, find CB, this length right here. So what they're testing us on in this problem is the perpendicular bisector theorem. Do we know what the perpendicular bisector theorem is? What the perpendicular bisector theorem tells us is that if you have a line segment like this and you draw a perpendicular and it bisects it, meaning it cuts it in half, if you pick any point along this line, say for example right here, what do you know about the distance to this endpoint and the distance to this endpoint? Well, they're going to be congruent. And the reason is because you see how they share this side by the reflexive property? These two triangles are going to be congruent by side angle side, side angle side. So by CPCTC, the corresponding parts of congruent triangles are congruent. So that's what we have here. We have a perpendicular bisector. Therefore, we know that CA is congruent to CB. We just have to do the algebra now, set the two segments equal to each other, and we see that x equals 8. It wants to know the length of CB, which is right here. We just have to put 8 back in. That's 24 plus 7, which is 31. Okay, so that's the perpendicular bisector theorem. So review that one if you need to. Here, what they're testing us on is the angle bisector theorem. We've got two angles that are congruent, which means that this ray here, DB, okay, is an angle bisector. It's cutting this angle in half. But just a quick review on the angle bisector theorem. What it tells us is if we have an angle and we bisect it, meaning we cut it in half, if we pick a point anywhere along this ray, okay, and we measure the perpendicular distance to the sides of the angle, then those lengths are going to be congruent to each other, okay? And the way I like to explain it is that if you're going down a river and it's getting wider and wider, but you stay to the center of the river, you fall out of your canoe or your boat, should you swim to this shore or to this shore? Well, it shouldn't really matter, right? Because you're right in the middle. But the thing is when you measure the distance from a point to a line, you always want to measure the perpendicular distance. That's the shortest distance, okay? And again, you can prove this because if these angles are congruent and they share the side between the two triangles, by the angle side triangle congruence theorem by CPCTC, you could show that these two lengths are the same. Okay, but to make a long story short, here we don't know that BC and BA are perpendicular to the sides of this angle, so we really don't know. I mean, this might be 90, it might be 89 degrees, we don't know. Even though this is an angle bisector, we can't show that BA is congruent to BC. There's not enough information. Okay, so that's a little bit of a trick question there. Number 32, it says find the centroid of the triangle with the vertices given. Now, what's a centroid? Well, centroid, it's basically like the center of mass. Like, it's the point where if you were to cut that triangle out and balance it at that point, it would be perfectly balanced. Okay, it's like the center of gravity, center of mass. And basically all it is like an average. You add the x coordinates together and you divide by 3. Not 2 like the midpoint, it's 3 since you have 3 points. So let's do that. Negative 2 plus 3 is 1, plus 8 is 9, divided by 3 equals 3. And then 6 plus 4 is 10, minus plus a negative 4 would be 6, and 6 divided by 3 equals 2. So our centroid is going to be at 3, 2. Okay, that's the center of mass. So just like an average, add up the x coordinates divided by 3, add up the y coordinates divided by 3, and you got it. Which angle is the largest? Okay, so they give us this triangle here. Now, remember when we talk about angles, we're basically thinking about hinges, right? An angle is like a hinge, okay, like a door hinge. And when you look at the side that's the longest, if you look across from that side, that's going to be the largest angle. And then the one across from the shortest side, okay, like that, that's going to be the smallest angle. And then, of course, the medium across from the medium side. So it's like a hinge. In order to open up to the widest side like that, the angle across has to be the largest. So in this case, angle B is what we're looking for here. And vice versa. If we knew that angle B was the largest angle, 130 degrees, say, for example, across from that angle would be the longest side. Okay, number 34 says, if a triangle has side lengths of 7 and 3, what is an interval for the length of the third side? Okay, so this is a very good question. So the thing is let me see if I can show you with an example here. Like, grab some props here. Okay, so here we've got this marker, and here we've got this eraser. And you can see this is like a hinge, okay? So you can rotate this, right? So for example, if we have 7 like this, and 3 like this, see the longest that this third side would be is if you open it up at a 180 degree angle like this. So if this was 7 and this was 3, the longest that that third side would have to stretch would be to 10, right? So we're going to put 10 over here. Okay, and then The smallest it would be is if we rotate this down like this, okay? Then it would only have to span from here to here, okay? So let's see if I can draw that. So here's 7, here's 3 going back this direction, right? Now it only has to span from here to here. That length is going to be 4. Now it can't be exactly 4 and it can't be exactly 10, because if it was exactly 10, this would actually fold flat, okay? And same thing here, if this was exactly 4, this would be folding flat. So we want some space in there to actually form a triangle. So as long as you're in between 4 and 10, not including 4 and 10, that's the range or the interval for the length of that third side. Now for number 35, it says, can a triangle be made with side lengths of 3, 6, and 9? Okay, now this is testing us on the triangle inequality theorem, just like with the last problem. But the thing that you want to check is that when you add any two sides up, they always have to be greater than the third side. So again, 3 and 6, that adds up to 9. That's not greater than 9. Okay, so like let's look at an example of another triangle. Like say if you had a triangle like 5, 6, and 7. See, 12 is greater than 6, 13 is greater than 5, 11 is greater than 7, and so on. That forms a triangle. But here, 3 plus 6 is 9. 9 is not greater than 9. Okay, it's equal to 9. It's not greater than 9. So in this case, you can't form a triangle like that. It would actually be the scenario where it's lying flat. Like you got 9, here's 6, here's 3. It just barely reaches, but it's compressing flat. So can't make a triangle with those 3 sides. Okay, question number 36. They give us these two triangles here, and it says, given that AC, okay, this length, is greater than DF, this length, solve for possible values of x. Okay, so here what they're testing us on is, notice that these two sides are congruent to these two sides, but they're telling us that this side is greater than this side. So basically, think about taking, two line segments, say like this marker and this orange pencil, right? And if this third side right here is longer, okay, what happens to this angle? Well, you can see it's actually becoming larger. So basically, we know that 6x minus 8 has to be greater than 4x plus 12, okay? So all we have to do now is solve this. I'll subtract 4x from both sides. I'm going to add 8 to both sides, divide by 2. As long as x is greater than 10, okay, we know that this angle is going to be larger than this angle, which means that this side is going to be longer than this side, okay? Up until a point, obviously, because, we don't want this angle to be, more than 180, and it wouldn't even form a triangle and so on. But basically, as long as it's greater than 10, that's going to make this larger than this angle. It's going to open wider, right? Okay, now number 37, it says the angles in a triangle are in the extended ratio. Okay, so they're talking about extended ratios here, 1 to 2 to 3. Okay, there's a little bit of a trick to this problem. It says find the measures of the angles, but once you see it, you've got it, okay? And the key is that, just say here's our generic triangle. Say this is 1, 2, 3, right? What you want to do is you want to add a variable in there, like for example, x, 1x to 2x to 3x. That's still in the ratio 1 to 2 to 3, right? But in a triangle, all the angles add up to how much? 180, right? So 1x plus 2x plus 3x equals 180. Now we have an equation we can solve for x. So 6x equals 180. Divide by 6, you can see x equals 30. And by putting 30 back in here, I get 2 times 30 is 60, 3 times 30 is 90, 1 times 30 is 30. So these angles are in they're 30 degrees, 60 degrees, and 90 degrees, which is a 1 to 2 to 3 ratio. So again, the key with the extended ratios is to add in that variable. Usually I use the letter x, it doesn't matter what the letter is, and then all the angles in a triangle up to 180, so you can write your equation. Okay, so you with me on that one? Okay, so for number 38 now, we're getting into some proportions, and it says which is not true. So if x divided by 2 equals 3 divided by y, we know that's true. Which of these is not true? Okay, so testing us on the properties of proportions. Let's look at the first one. The first one, you can see they're taking the reciprocal of the left side, and they're taking the reciprocal of the right side. So yeah, that's true. And the way you can kind of check it is, see if you cross multiply, see x times y is equal to 3 times 2, which is 6. Same thing here, see x times y equals 6, right? So those are equivalent. Okay, now let's look at letter B. Now notice what they're doing with letter B. They're actually interchanging the 3 and the 2 on the diagonal, okay? Which is perfectly fine, because when you cross multiply, see x times y equals 3 times 2, which is 6, we're getting the exact same thing. So these are good, so I'm going to cross those out. Those are true. We're looking for which one's not true. Let's look at this one over here. Now this one tends to stump students. Now notice it looks a little bit, quite a bit different than the original one. But notice what they're doing is they're adding this denominator 2 to the numerator, and they're adding this y the denominator to the numerator. But what I like to do is I like to split this up into two fractions like this, okay? So you follow me on this? See, x over 2 equals 3 over y. That's our original equation. But what's 2 over 2? That's 1. What's y over 1? That's 1. It's like adding 1 to both sides of the equation. You're keeping it balanced, right? You're not changing it. So this is actually a true statement, okay? If you add, you take an equation, you add 1 to both sides, it's still going to be equivalent, right? Okay. Now the last one, let's double check. We've got y over 2 equals x over 3. What do they do to get to that position? Well, it looks like they switched the x and the y, and they took the reciprocal. So they kind of combined, they kind of mixed and matched. But notice when you cross multiply here, you get 3y equals 2x, which is nothing like x times y equals 6. So here again, just to quickly review, so the letter D would not be true. You can switch these on the diagonal, okay? You can take the reciprocal of both sides, and you can add the denominator to the numerator as long as you do it on both sides. You're adding this denominator to the numerator, this denominator to the numerator. It's like adding 1 to both sides. So those are the properties of proportions. Review that if you need to. Number 39, it says if the legend of a map says that 2 inches equals 25 miles in real life, right? How far on the map is the distance of 175 miles in real life? How far would it be on the map, right? So again, talking about the theme of proportions, we've got 2 inches for every 175 miles, x inches for how, I said that wrong, didn't I? 2 inches for every 25 miles, right? 25 miles, x inches for 175 miles. The key here when you do proportions, though, is you're comparing apples to apples, right? Oranges to oranges. We've got map to real life, map to real life. This ratio is the same as this ratio. So scale to actual is how I sometimes say it. So when you cross multiply, this is the means extremes property, you cross multiply 25x, right, equals 2 times 175, which is 350, divide both sides by 25, and what does that come out to? Is it 14? I think it's 14. Let me double check real quick. 25. Yep, 14, so that's it. So that it would be 14 inches on the map. And remember, when you do your word problems or your story problems, you want to put your units, right? Okay, so on number 40, they give us this triangle here. Notice they draw this line here, XR, which is parallel to the base, YZ, okay? And so this is called the triangle proportionality theorem, or sometimes they refer to it as the side splitting theorem, because see, this XR splits the sides of this triangle into 2 pieces, right? And so here's how it works. I'll just show you the property real quick. So if this is parallel to this, you've got A, B, C, D. The ratio of A to B is the same as the ratio of C to D. So this segment to this segment equals this segment to this segment, as long as this line is parallel to the base. Okay, so that's what we're going to do here to solve for x, y. I'm just going to call this x, okay, for the unknown. So we've got 6 is to x as 5 is to 2. Cross multiply, we get 5x equals 12. Divide both sides by 5, and we get x equals 12/5, and you got it. If you're enjoying this video and you like my teaching style and you're preparing for the ACT Math section or the SAT Math section, check out my 2 video courses, my huge ACT Math Review video course and my huge SAT Math Review video course. Geometry plays a big role in both of those tests. I mean, in addition to Algebra 1, Algebra 2, pre-algebra, trigonometry, geometry is one of those key pieces as well. And we're going through some of the concepts here, but there's additional concepts in that course specifically focused on those 2 tests. So check out the 3 free previews on both those courses to see if it's a right fit for you. A lot of students have taken the courses already and have boosted their scores and reported back that it's really helped them. So I'm sure it'll help you too. But let's continue on with this course. Also, I wanted to mention that if you're preparing and you need some help with some online tutoring, I'm available for online tutoring as well via FaceTime or via Skype. We can do either of those, and we've got a shared whiteboard that we can use in addition. So reach out and contact me if you're interested in that. Otherwise, let's keep going on with this video here. Number 41, what they're telling us is that lines L, M, and N are all parallel. So all 3 of these lines are parallel, and they're cut by 2 transversals like that. And it says find the length of HI, so I'll just call that length X. Now this problem is very similar to the last problem we did, number 40, but when you have 3 parallel lines cut by 2 transversals, let's just call these 2 pieces A and B, these 2 pieces C and D. The ratio of A to B is the same as C to D. So that's the key formula here. So what we're going to do is we're going to say 6 is to 8, right? 6 is to 8 as 7 is to x, okay? And then all we have to do is cross multiply. 6x equals 56. divide both sides by 6, and so you can see that's going to be 28/3. Okay, so you're with me on that one? Okay, number 42, they give us this triangle here, and they bisect this angle. See how these two angles are congruent, and wants us to find x. Okay, so this is the angle bisector theorem here, and what we have here is we have the ratio of 2:3 as x is to 7. You can think of like taking this and folding it over like so. So 2 matches with 3, x matches with 7. We make a proportion 2:3 as x is to 7. Cross multiply, 3x equals 14, and divide by 3, x equals 14/3, and you've got it. Okay, number 43, it says, given that triangle DEF is similar now to triangle GHI. Now remember, similar means that the corresponding angles are congruent, but the corresponding sides are proportional, okay? So they're in the same ratio. And it says, find the scale factor from triangle DEF, this one on the left, to triangle GHI, this one on the right. And then part B says, find the length of side X here, HI, okay? Now here's the thing, when you find the scale factor, what you want to do is, if you're going from the left to the right one is the new one. So the scale factor, it's the new divided by the old. Okay, so in this case, if I'm going from 6 to 20, I'm going to take 20 divided by 6, and you can reduce that to 10/3. Okay, if I was going from the right one to the left one, then I would take 6 divided by 20. Okay, and you know you're on the right track, because if the scale factor is greater than 1, it's an enlargement. If the scale factor is smaller than 1, it's going to be a reduction. Okay, it's getting smaller. Okay, now in the second part it says find x. Now this is a little bit easier. You just have to make sure you're matching up the corresponding sides. So let's see, I'm running out of room here, so let me see if I can just put it right here. So it says 9 is to x, okay, 9 is to x as 6 is to 20. Then all you have to do is cross multiply. So we have 6x equals 180, so divide by 6, x equals 30, and you've got it. So the key here is, when you're looking at a similarity, you want to make sure you're matching up corresponding sides. So see how DE is to GH, and EF is to HI, and DF is to GI. So first and third matches up with first and third. So that's how you can match up the corresponding sides. Okay, now number 44, it says, are the triangles similar? Okay, yes or no, and if they are, write the similarity statement. Okay, now remember, we talked about proving triangles earlier. There was 5 ways, right? But to prove triangles similar, there's only 3 ways. Okay, there's the angle-angle similarity, there's the side-side-side similarity, and then there's the side-angle-side. So angle-angle means that 2 angles in one triangle are congruent to 2 angles in another triangle, and then automatically the triangles are similar, meaning the corresponding sides are proportional. Side-side-side, we have to show that 3 sides in one triangle are in the same ratio as 3 sides in another triangle. And then side angle side, the 2 sides have to be in the same ratio from one triangle to the other, but the angle in between those 2 sides, the included angle, has to be congruent, meaning it has to be the same. So here, when we look at this overall triangle and this smaller triangle, you can see that they share angle V. Okay, see how they're like overlapping at angle V? So what we have is this angle and this angle are congruent to this angle in the larger triangle. So yes, they are indeed similar, and it's by the angle-angle similarity. Now to write the similarity statement, I'm going to say triangle STU, that's, I'm sorry, it's STV, that's the big triangle. STV is similar to triangle WUV, okay? So you want to make sure you're matching up the corresponding angles and the corresponding sides. And number 45 says, which triangles are similar? So they give us 3 triangles here. Is it DOG, dog, CAT, cat, or XYZ? Well, what you want to do here, and I'll give you a little hint, we're going to do 2 at a time, either these 2, or these 2, or these 2. The key is you want to match up the smallest side with the smallest side, medium with medium, and longest with longest, okay? So say I want to compare these 2 sides here. I'm going to say short to short, so that's going to be 3 is to 6, okay, question mark. Is that the same as, let's see, 4 is to 8, 4 is to 8, as 5 is to 11. We can see 3 6 is 1/2, 4 8 is 1/2, 5 11ths, not 1/2. They're not all in the same ratio, so these 2 are not similar. Let's check the first and the third. So I'm going to compare short to short, medium to medium, long to long. So short to short would be 3 to 9, right? So 3 to 9, 4 to 12, so medium to medium, and longest to longest, so 5 to 15. oops, 5 to 15. Now if you reduce these, you get 1/3, 1/3, 1/3. Now they don't always reduce perfectly, so what you can just do is you can get a decimal. You could just divide 3 divided by 9, 4 divided by 12, 5 divided by 15. You're going to get 0.3333. For all three of these, you can see that they're the same, so we know that the first and the third are similar. And then if you wanted to write a similarity statement, you would just say, well, let's see. This is how I like to do it. I like to trace it out. So I do short side, medium side, long side. So see how I went ODG? ODG is similar to triangle 2. Let's do short, medium, long here. So that would be X, Z, Y back to X. So X, Z, Y. You don't have to do it that way, but I find it to be easier. So you're tracing short side, medium side, long side. And same thing here, short side, medium side, long side. That way you know you're matching up the corresponding sides. Okay, last two questions. So number 46, it says determine if the triangles are similar, and if they are, what is the scale factor from figure 1 to figure 2? Okay, so it looks like what they're giving us here are two triangles, one larger than the other, and it looks like they're giving us a side, an angle, and a side. And the angle is in between the two sides. So remember, there's three ways to prove triangles similar that we learned: angle, angle, side, 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 and side, angle, side. And that's what we're focused on in this problem, is the side, angle, side technique. And so you can see that angles are congruent. Okay, so we got that. Let's check that off the list. Let's compare the corresponding sides. Now I want to compare the longer one to the longer one, the shorter one to the shorter one. So 8 is to 2, okay, 8 is to 2, question mark, as 12 is to 3. So are those the same? Well, 8 divided by 2 is 4, 12 divided by 3 is 4. Yes, that's true. So the corresponding sides are proportional, and these triangles are similar by the side angle side similarity theorem, okay? But now it's asking us, what's the scale factor from figure 1 to figure 2? Now again, like we talked about in the previous problem, you want to take the new over the old, right? So if you're going from 1 to 2, the new length is going to be 3, the old length is 12. So that's a scale factor of 1/4, which makes sense because 1/4 is less than 1. It's shrinking. It's a reduction. If we were going from here to here, it'd be an enlargement, and it would actually be the reciprocal of that scale factor. It would be 4/1. So it'd be 4, be getting larger. Okay, last question. It says, given segment AB with A 2, 8 and B coordinates 1, 4, find the coordinates of point A, this guy here, after a dilation of 5/2 centered about the origin. Okay, so what we're talking about now are dilations. Okay, so making it larger or making it smaller. And here's the thing, if you know point A is 2, 8, you know the scale factor is 5/2, all you have to do is multiply the x coordinate and the y coordinate by that scale factor. So if we do that, remember this is like anything divided by 1 is itself. So if I multiply the numerators and denominators together, I get 10 divided by 2, which is 5. And here I get 40 divided by 2, which is 20. So the coordinates of the new point A prime after that dilation of 5/2, 2.5 times larger, these are going to be the coordinates of point A. So I hope this video helped you to do better when you take your geometry midterm exam, or if you're just reviewing your geometry concepts. I hope this helped you a lot. So subscribe to the channel, check out more geometry videos on my YouTube channel, Mario's Math Tutoring, and I look forward to helping you in the future videos. I'll talk to you soon.